Hear me or not?
Okay.
Okay. Now, this part is correct. This part is correct. This one is wrong. This one is wrong. Now, this one, the original one is xy. X1 is these two. Now, when you differentiate the x, you have to keep the y. So this one should be y. Then the next part, when you keep the x, you differentiate the y. This is what you get when you differentiate the y, 1 dy dx. But you didn't keep the x, so there should be x here. There should be x here. So this should be y, this should be y, this should be x, according to this side. Y plus x dy dx. Y plus x dy dx. So this part is the mistake. Okay. Then the other one, this one. This is the other one. Okay. This one is, I don't know the question. I look at the question first. 3, so it's 6, 2xy. Okay. So the question is number 12, is it? 12, 3x squared is 6xy. This is correct. Okay. So this is correct. Okay. 2xy. Okay. 2xy. This part differentiate you keep the 2x, is it? Then if you differentiate the y, there should be a dy dx here. When you differentiate the x, then there should be only be 2y left. Okay, there should only be 2y left. Okay, let me type out again. So maybe it's not so clear. We just look at this 2xy here. 2xy minus 2xy. So when you differentiate which one, let's say you differentiate the negative 2x, become negative 2, right? Then you keep the y, plus, just now you differentiate the negative 2x. Now you keep the negative 2x, you differentiate the y. Differentiate y become 1. Differentiate y with respect to x become dy over dx. Okay. So this part here, this is correct. 6x is correct. This part here should be like this. Then you differentiate 8. This is correct. 8y, then you put dy dx there. Differentiate this one, become 1, correct. Differentiate 2y, this is correct. So everything is correct except the one involving the product rule. So when you differentiate using the product rule, you must know which one you differentiate, which one you keep. In the first case, you differentiate the x, you keep the y. Right? In the second case, Oh, sorry, there's mistake. There's a mistake there. You differentiate the x, you get -2, then you keep the y. Now you keep the -2x, sorry. You keep the -2x, then you differentiate the y. It should be like this. It should be like this. You keep the -2x, you differentiate the y, then the differentiate y, you have to put down dy dx. So this whole thing here, I clear up everything. Clear all everything. Okay. So everything is correct here. This is correct. Only this one. This one. Only this one wrong. And this one, what is the answer? The answer is this. This one correct. All the rest all correct. So you just copy down this, right? Copy down this. Then later you do the corrections. You know, you just copy this.
Mm.
Okay, finish. Finish.
Mm.
Have you finished copying?
Yes.
Okay. Now, where are we now? This one, Then here, clear all the drawing. Then we go to this one. Okay. Okay, right. So we are going to look at differentiation. After differentiation, we're going to look at integration. Now, what is integration, right? Integration is actually the inverse of differentiation or the reverse of differentiation. Now, if you remember when we studied differentiation, the first time I told you differentiate with respect to x, d dx of this function fx, the symbol is f prime x. F prime x means the dy dx. F prime x means the differentiation of fx. It is not fx, but it is the answer after you have differentiated fx. Okay or not?
Mm.
Can follow or not? I repeat, never mind. Now, at first, we have a function fx. The original function is fx. Then I want to differentiate with respect to x, meaning d dx, this function fx. I want to differentiate fx. So when I differentiate fx, it is called f prime x. Is f prime s x fx? No. F prime x is the derivative of fx. Now, if you differentiate fx, you get f prime x. So you integrate. This is the integration sign. If you integrate f prime x, you should get back your fx. That is the meaning of integration. Means you integrate, you get back the original function. Okay or not?
Okay.
Can. Okay. Now, if you cannot, then afterwards we have plenty of example to show you, right? So don't worry. Okay. Now, it means like that. If you have a function fx, you differentiate with respect to x, you get f prime x. If you have the function f prime x, you integrate with respect to x, you get back your fx. The picture will show you clearly what I mean. Is this okay?
Mm.
Okay.
Okay.
But how you go from left to right. You go from left to right, you have to differentiate with respect to x. You go from right to left, you have to integrate with respect to x. Okay, so that is the meaning of differentiation. So now we look at the actual example. Let's say I differentiate this 3x squared plus 5x. What is the answer? Differentiate 3x squared is 6x. Differentiate 5 is 0. Is 0. So if I integrate this 6x with respect to x, you should get back 3x squared plus 5. Okay or not?
Okay.
So that is the meaning of integration. If you differentiate something, you get the answer. You integrate the answer, you should get back the original function. That is the meaning of it. One more example, right? Now we write in fx form. Fx equals to 3x squared plus 5. F prime x equals to 6x. So if you integrate 6x with respect to x, you get back 3x squared plus 5. Okay? Right. So now we look at this. We look at this example here. Another example, I differentiate 3x squared minus 7. The answer is 6x. Then if I integrate the 6x, integrate 6x with respect to x, I should get back 3x squared minus 7. Okay, right. So in general, that means let's say if you want to integrate this 6x dx, integrate 6x, sometimes you get minus 7. Integrate 6x, sometimes you get plus 5x. Oi, funny, oh. So the number at the back there, it depends on the original function that you differentiate. Right or not? Can follow or not? Because the number at the back, the constant here, you integrate 6x, you get 3x squared plus 5. You integrate 6x, you get 3x squared minus 7. So the number, the function is always correct. It's 3x squared. This is 3x squared. It's always correct. But the number at the back can change one. So in general, let's say if I want to integrate this 6x with respect to x, I have 3x squared. For sure, I have 3x squared. But the number at the back there, not sure. So I don't call it 7 or 5 or what. I call it C. C. What is this C? C is actually a number, like this -7 or +5. But what is the actual number? I don't know. That's why I call it C. So in English, we say, oh, C is an arbitrary constant. Arbitrary constant means it can be any constant. Arbitrary, you simply go and choose one number and say that is the constant, right? It can be any number. Sebarang, in bahasa Melayu is sebarang. Sebarangan, any constant, right? So remember, when you integrate a certain function, there is always an arbitrary constant at the back there, because we don't know the original function. Of course, if you know the original function is -7, of course, answer is -7 lah. If you know the original function is +5, of course, the answer is +5 lah. But you don't know one, then you call it C. Can follow or not so far?
Can.
Okay. Next one. Now you have this one, right? y equals to 2 bracket 3x plus 1 raised to the power of 4. Find dy dx. Hence, find the integration of 3x plus 1 to the power of 3 with respect to x. What they are trying to say is that, hey, you don't know what is the answer or differentiate this one. Try to differentiate what is this. So we try to differentiate. When you want to differentiate this, according to the question, you want to find dy dx. So why is this? Dy dx means you bring down the power less by 1, then you differentiate what is inside. Differentiate what is inside. Differentiate what is inside, you get 3 lah. Differentiate 3x, you get 3. Differentiate 1, 0 lah, don't care. So when I multiply these numbers together, 3 times 4 times 2, answer is 24 raised to the power of 3x plus 1 cubed. So this is the differentiation of the given function, the first derivative of the given function. This is the answer. Right? This is the answer. So when I integrate this 24 blah 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 blah, I should get back this one, no? Right? No? When I integrate this 24, then to the power 3, I should get back 2 to the this thing, then to power 4. That is the reverse of differentiation. So I write down lah, integrate 24, this thing all, equals equals to 2 plus x plus 1 raised to the power 4. What it means is like this. What it means is like this. When you differentiate this now, when you differentiate this, you get this. So when you integrate this, when you integrate this thing, you should get back this one. Understand? Can or not?
Can.
Can. So then I write down this. That means you can follow what I'm writing here. Right? Not? Integrate this, you get back this. Okay, not?
Okay.
Okay. So this is the answer. But if you look at the question, they say, find, integrate 3x plus 1 to the power of 3. They didn't say they want the 24 in front. So I must move this 24, go to the other side. So I will move the 24 to the other side. So the actual integration of this thing is 2 over 24, 3x plus 1 raised to the power 4. Is this okay? Can follow or not? Okay. Then I cancel, then I have 1 over 12. So the answer should be 1 over 12, this thing. So this is the answer. So this is the meaning of integration. Okay, right. Okay, right. The next question is, they give you the function y. Give you the function y. Then ask you to find dy dx. After you find dy dx, they ask you to integrate this thing. So altogether, you need to do 2 things. First thing is to find the dy dx. The second thing is to integrate this. Do you remember how to use the quotient rule to differentiate this? Yes. Quotient rule say you differentiate x minus 1. Answer is 1. Then you keep this 2x plus 1. After that, you differentiate the bottom here. 2x plus 1. Answer is 2. Then the top, the whole thing, you keep. The whole thing you keep. So when you simplify, this is 2x minus 2x. No more already. Then 1 plus, oh, there's a 1 here. 1 plus 2 is 3. It's not 2. Mana dia, oh. Cannot change. Oh, this is wrong. Oh, this is wrong. How to put it? Yeah, this is wrong. This is not 2. This is not 2. Answer is 3. Answer is 3. Can you see why it is 3? Can you see why it's 3? Now you multiply out. Multiply out. Multiply out. This is 2. This is 2. This one multiplied by this is 1. This is 2x. And this one multiply here, 2x. This one multiply here, positive 2. This is positive 2. Negative 2 multiplied by negative 1 is positive 2. 1 plus 2, answer 3. It's not 2. Type wrongly. Okay, so this is our dy dx. So our dy dx is 3 over 2x plus 1 squared. So far, okay or not? Can follow or not?
Can.
Okay. Then we want to integrate this. You integrate this, you should get back the original answer here. Integrate this, you should get back the answer here. This is not 2, it's 3. This is 3. Okay. Okay. So when you want to find 1 over 2x, 1 over 2x, you should bring the 3 over here. So you should be, this one should not be 2, it's not 2, but you should bring the 3 over. There should be 3. Okay, right. So this is the meaning of differentiation. Before I carry on, can follow or not this one? Can you follow this? Any question?
No.
So you integrate this, you should get back the original function. But sometimes they have no number there. But your answer actually got number, so you have to bring the number over to get the actual answer. Okay, right. So we move on. Oh, this one no need. This one no need to move on. Okay. Now that is the meaning of integration. But we are not so lucky. Every time they will ask you, hey, you differentiate first, then you get the answer, then you integrate. No. Sometimes they ask you to integrate straight away. They don't give you the original function. They ask you to integrate straight away. So if you want to integrate straight away, this should be the formula for you to integrate. Let's say you want to integrate ax to the power n with respect to x, then the power of x you must increase by 1. Then you divide by the new power, then plus the arbitrary constant. So it will be something like this. Okay, there's something like this. If you want to integrate x, you have to increase the power by 1, then divide by the power. Now, earlier on, when we do differentiation, what we did was you multiply with the power, then the power less by 1, right? No? But now, integration is the opposite process. You increase the power by 1, then you divide by the power. Okay. Earlier on, we multiply with the power, power less by 1. Now, we increase the power, power divide instead of multiply with the power. If you don't know what I'm talking about, we have examples.
Yes.
Examples there. Okay, what is the example? The example is, I want to integrate 5x squared with respect to x. Now, this 5 is a number. You don't have to integrate the number. So you just copy down the 5. Then x squared. You want to integrate x squared, you have to increase the power by 1. So 2 plus 1 become 3. Then you divide by the new power, the new index, 3. Then plus the arbitrary constant c, because we don't know the original function. So we don't know what is the constant there. So we just put a c there to represent there is a number, but we don't know what is the number. That is the meaning of c. Okay. So now I have shown you how to integrate the function where the index is a positive number. See here, the index is positive 2. Positive 2. Now, what happens if we have this type of function? 2 over 3x squared. Can I say square, we increase by 1, then become power of 3? No. Why? Because these 2 at the bottom there, it means x to the power of -2. So you have to bring up first x power -2. Then this number 2 over 3 don't change. 2 over 3 is actually a number, so you don't integrate the number. So you leave it as 2 over 3. You see the 3 is at the bottom. You don't bring the 3 to the top together with the x. Cannot, cannot. So you leave the number at the bottom, but the x, the variable x, you move to the top and become x to the power -2. Can you understand what I'm doing?
Yes.
Yes. Numbers, don't do anything to them. Just leave it as they are. Just now 5, you just leave it as 5. Now it's 3 over 2, you just leave it as 3 over 2. Then this x become x to the power -2. Now what I've been doing so far is I simplify the function from 1 over x squared to x to the power -2. Have I done the integration? No, I didn't integrate yet. So if I didn't integrate yet, the integration sign is still there. The integration sign is still there. So now I'm going to integrate. Number 3 over 2, you just leave it there. Then this one, -2 plus 1 become -1. Then you divide by this new index, -1. Then plus c. Now, after I have increased the power by 1, I have already integrated. So if I have integrated, there is no more integration sign there. You know what I'm talking about?
Mm.
Okay, or not? Can follow or not?
Can.
Can. Okay. So next part. Now this x to the power -1 is actually 1 over x. This negative sign you can put to the front. So it's actually -2 over 3. And this thing is 1 over x. Okay, then plus c. Or we can actually simplify further. Simplify further means the 2, you multiply with the 1, you get 2. 3 multiply with the x, you get 3x. So it's negative 2 over 3x plus c. So far, can follow or not this question? Can, okay. What I've been doing here is this index here is a positive number. I show you how to integrate. This index here is a negative number. I show you how to integrate. Now, what happens if the index is a fraction? It's something like this. Now, what is the meaning of this? Square root of x cubed. Square root means is half. Then cube, you put at the top there. So what you want to integrate square root of x cubed means you want to integrate x to the power of 3 over 2. Where the 3 come from? The 3 come from here. Where the 2 come from? The 2 come from the square root. So I want to integrate a function with fraction, the index as a fraction. So index is a fraction. So the same thing, we are going to do the same thing, right? We are going to increase the power by 1, then we are going to divide by the new power, right? So how? So x to the power of 3 over 2, then you plus 1, then you divide by the new power here. This is the new power, 3 over 2 plus 1, then plus c. Okay, all right. So with this 3 over 2 plus 1 is 5 over 2. So it's x to the power of 5 over 2 divided by 5 over 2. Not good enough, but you still need to simplify. Now, how to simplify? Divide by 5 over 2 means multiply with 2 over 5. So multiply with 2 over 5. Is that okay with you?
Yes.
Yes, okay. So far, we have simplified the number part. The index part, 5 over 2, we have not simplified yet. So how to make this 5 over 2? 5 means the power of 5 here. The 2 at the bottom here means the square root. So it's square root of x to the power of 5. So this is the answer. Okay or not?
Okay.
Okay. Now, this formula here enable you to integrate any function. The x with any power, a power of whole number power that is a negative number power that is a fraction. You can integrate any function involving x using this formula here, except when the power is -1. You cannot use this formula to integrate when the power is -1. Because if you integrate +1 become x to the power 0, then you have to divide by 0. Divide by 0 is infinity. Divide by 0 is undefined. So you cannot. So this formula only allow you to integrate functions with power not equal to -1. It can be a positive whole number, it can be a negative whole number, it can be a fraction, but never -1. If it's -1, you cannot use this formula. So what happens if the power is -1? Okay. X to the power -1, when you want to integrate with respect to x, means you want to integrate 1 over x with respect to x. The answer is ln x. Answer is log x. Not log base 10, but log base t. This is called natural log. Have you learned this in this one?
Oh.
No natural log. You don't learn natural log,
Oh.
No, then you don't care about this thing, Don't care about this thing. Ln x is actually log base e